is the world of 1947. Figuratively, it is early spring in the age of atomic energy, opening days in man's search into the core of matter. The calendar says it is autumn at Cambridge. Work is being carried on at the Massachusetts Institute of Technology, which will have a vital effect on future tests of 3 new and improved atomic weapons. The Atomic Energy Commission, slated to conduct Operation Sandstone at a Pacific proving ground, has obtained the services of 3 members of the MIT staff, the consulting engineering firm of Edgerton, Gurmishausen, and Greer. These 3, together with their staff, are charged with devising the complex timing signals and remote control firing circuits necessary to detonate the weapons and switch on myriad self-recording equipment at the right sub-fraction of a second. In addition, these experts in the field of electronics will conduct the highly important Teller Alpha experiment, an aid in determining weapon efficiency by recording visible effects of neutron multiplication. At the same time, Edgerton, Gurmishausen, and Greer are formulating plans and designing special equipment. An advanced element of Joint Task Force 7 is surveying AEC's permanent test ground, Eniwetok Atoll. More than 4,500 miles west of the California coast, in the heart of the Marshall Islands in the Central Pacific, the EGG staff, experts in measuring time intervals by means of electronic circuits, will correlate the many varied experiments and tests on a single timing system. Without this work, a major part of the proposed scientific analysis would be impossible. The task force, made up of scientists and members of the armed forces, will find the tropics has more than travelogue scenery. Let us examine the magnitude of the electronic circuits to be installed at Eniwetok Atoll. There will be a master control station electrically directing the entire operation. Individual timing stations will be constructed on the 3 detonation islands. Instrument installations and timing stations will be connected by cables. Each timing station will be joined through its adjacent neighbor to the master control station by submarine cable network. The 3 atomic detonations will be photographed successively from photo towers at points adjoining the 0 islands. The photo towers, in turn, will be tied into the electrical network. A photo station will be set up on a shoal in the middle of the lagoon. The shoal tower and the headquarters island will also be connected to the electrical network through the submarine cable. In this manner, various key points on the atoll will be joined in the split-second timing circuit. Time and distance are telescoped as we turn to the West Coast. Here, during the opening days of 1948, the logistics plan of Operation Sandstone goes into effect. Vast amounts of materiel are required to supply the 10,000 men of Joint Task Force 7. Part of the supplies is equipment which will be used to detonate and analyze the atomic weapons and definitely prove the theories of AEC scientists. EG&G materiel is among the equipment being transferred to the holds of transports. Engineer troops and other advanced personnel are Eniwetok bound. Scientists will follow later. At the atoll, engineers get down to business. In clearing the islands of thick tropic vegetation, they encounter foes which bulldozers cannot push aside. Dust, heat, harsh sunlight, humidity. This is the price of scientific development. These are the conditions under which scientists will work. Here, on-the-spot modifications will be accomplished to meet exacting complex requirements of tests which are of great magnitude and will be staged in extreme secrecy. Working to EG&G specifications, engineers construct the master control station. Instruments in this building will set into action timing circuits so that each piece of testing equipment on the atoll will become operational at the exact specified moment. Meanwhile, Greer, Edgerton, and their staff are among the scientists heading westward behind a curtain of security. Other staffmen have preceded them overseas to supervise early construction. Still others will remain in the States for liaison. No sooner has the convoy steamed out of port than scientists head for shipborne laboratories to check equipment and continue planning. The control island, nerve center for the tests, where vital instruments have been placed in the master control station. To protect valuable circuits and scope cameras, an air conditioning unit has been installed. Many circuits and sequence timers have been specially designed by EGG to meet exacting Sandstone requirements. Lieutenant Gilbert and Barney O'Keefe check various panels. O'Keefe examines the installation. Then he and Herb Greer discuss the next steps in the operation. Sand is piled around the timing stations to protect delicate mechanisms from blast and radiation effects. To further screen certain instruments from radiation, lead bricks are brought into the timing station and placed by Tommy Thompson of NRL. The EG&G staff played an important part in the development of these high-speed recording oscilloscopes to be used in several experiments. Since each timing station is a relay point, as well as the site of a particular test, direct communications are established. Naval and Coast Guard personnel place the basis for the signal network by laying approximately 1 million feet of submarine cable in a prearranged pattern. It webs out from the master control station to various other islands of the atoll. Buried in a shallow ditch, the cable extends to the timing stations and other major installations. Cameras in the shoal tower and the other photo towers are among the highly important equipment tied into circuits for remote control operation. Photo analysis will give the AEC vital information that can be obtained in no other way. The human eye cannot transmit to the brain the pictures that it sees in a millisecond, but the camera, set into action by electrical impulse, holds its pictures for later deliberate inspection. Many types of cameras will be in use. The most important are fast tacks, which operate up to 9,000 frames per second and expose their entire footage in a fraction of a second. These are supported by other types, both still and motion picture, shooting black and white and color film at various speeds. For occasional moments of recreation, there's sunbathing, swimming, and even a bit of beachcombing. This resulted in an adventure for Charlie Wyckoff. He spotted an object floating at Surf's Edge, which turned out to be a film float from atomic tests held at Bikini in the summer of 1946. This ocean wanderer was the first found in almost 2 years. L-5 liaison planes darting from island to island of the atoll speed the scientists in their work on timing circuits. Scientific personnel commute daily to the test islands. The Teller Alpha experiment, devised in 1947 by Dr. Edward Teller, a University of Chicago physicist and Los Alamos consultant, involves the Zero Tower and the Teller Alpha reflectors. It is one of the important phases of EG&G work. Equipment centers in 36-inch Navy searchlights modified to meet scientific requirements. Inside are photosensitive tubes which will funnel light to recording instruments. Eberhard and Doc Edgerton make final checks. They also examine other equipment which will allow a variation phase of Teller Alpha. While a guard patrols near this vital installation, let us look at similar equipment at the control island, where Teller Alpha measurements will also be made. Members of the EG&G staff live and work aboard the Albemarle when they are not on the test and control islands. Here's Harry Smith in the fully equipped floating laboratory. Elsewhere, planning proceeds on equipment changes indicated by activities in the field. X-ray day is rapidly approaching. Last preparations are made. Oscilloscope cameras are loaded. top men in the operation are ashore for a final appraisal. Personnel, with the exception of a few key scientists who will remain until the last possible moment, are evacuated from the immediate danger area. The detonation party arrives at the master control station. Members of the EGG staff work with other Joint Task Force 7 scientists in these final actions. Dr. Greer closes the power circuits. Dr. Graves keeps his chief back on the command ship posted on developments, then actuates the sequence timers. With test time only moments away, final time signals are called by Colonel Preuss. Split seconds separate us from the detonation. Scientists and radiological personnel are on the test island to gather samples and other vital information. The powerful detonations have provided vital information on nuclear reactions and weapon efficiency. Members of the scientific staff, accompanied by radiological monitors, clear the approach to the timing station. Precious film from high-speed recording oscilloscopes is carefully loaded into a carrying case and immediately sent to the laboratory on the Albemarle, where Charlie Wyckoff begins detailed examination of the negatives. Not only will the negatives furnish information on weapon efficiency, but they will allow a comparison between the three weapons. While staff meetings are held to discuss results and formulate a final report, let's view the nuclear detonations which necessitated the complex timing pattern. The work of EGG was in keeping with the spirit of Joint Task Force 7, for EGG itself was a joint staff operation, having both its key scientific unit and the supporting military element. It has made a vital contribution to Operation Sandstone and helped broaden and extend the road of research in America's quest for atomic knowledge.